Welcome everybody to the Business of Machining. I am one of your hosts, John Grimsmo.
And my name is John Saunders.
How you going today?
You know, it's funny. Yesterday was not a fun day, and I think it actually ties really well into the title of this podcast, which is the Business of Machining.
Yep.
So when I first got started, I really liked this plan that we had, and we kind of knew it was the plan. It worked out even better than we had thought, which was, learn, model, prototype in-house, and then get smart, get comfortable, and then that helps you do a better job of growing the business as we dealt with other people. At the time, at the original start, I didn't even have my Tormach. I had that tag, and I was in New York City. I had a job, so owning real manufacturer equipment was out of the question. And so what happened was as we started outsourcing, we did actually a pretty good job of doing that, getting parts machined, because we learned trial by fire. So we learned from the mistakes that we made on, and all of this basically comes back to drawings. That's kind of my punchline of what stunk about yesterday. But making good drawings, making sure the part is what you want, making sure the drawing is not under or over constrained or toleranced, and then working with people that understand how to read the prints and drawings and so forth. And so we got, I think, pretty good at that, and I've come to really appreciate how you have to have everything in the drawings. It doesn't matter. Don't do it over the phone call. Don't do it in separate emails. Don't have duplicate sets of drawings, some of which have different information. The drawing is the key. And so what happened yesterday was we are working on sort of a contract manufacturing job where we had 2,500 parts that were out to get run. 500 of them were done incorrectly.
So this is a part you designed and had a drawing for, and somebody else made it?
I did not design it. I was involved in the design, but it's sort of somebody else's. I'm just, for lack of a better word, a consultant on the project.
Okay.
And actually, it's kind of funny now that you ask me that question. What the customer here is doing is basically using me as a consultant, because I've done this, and it's exactly the kind of hurdle that you don't want to go through when this particular part and job is not conducive to low runs. It's very difficult to make 10 of them. I won't go into more details, but we made a few in-house, and now we're doing the first batch of them. And the problem is, it was called out specifically on the print, or the issue that happened. It was a post machining finishing application, and so the shop called and basically said these were done wrong. And there was a little bit at first of the whole we're not sure, we're going to say it was our mistake, and then they quickly fessed up that it was their oversight. They have to take responsibility for it. And we're actually going to film a chip break on this because I think it's such a good topic. But I think the two takeaways were, one, you have to have everything in the print. It's so important to have that information there because that's what matters. But on the flip side, you've also got to remember it has to stay a win-win. Sure, people should fix their mistakes or pay for their mistakes, but that's not really always how the world works, especially when the numbers get bigger. And 500 isn't that big. We're not talking about huge amounts of money here. Thousands of dollars, not tens of thousands or hundreds of thousands. But nevertheless, to sort of put that example on pause and just go into the theoretical here, you could tell the shop we're not accepting the parts, or you could tell the shop we want you to rerun them. I don't think they have an obligation to rerun them. They could just now decline the job if they didn't like it because they misquoted it or misunderstood the application or something. But it doesn't do anybody any good. I'm frustrated because I actually spoke with them about the whole thing, including this specific thing they screwed up. And I know some of the folks listening may be saying, we are never going to use that shop again. And I would say, well, first of all, no, they didn't maliciously think, let's botch these. Very few, if any, companies ever actually maliciously intend to do that. And frankly, very few are even so sloppy as to let things like that happen systematically. The reality is goofs happen, things happen. So what do you do about it? And how do you go forward? And again, it kind of stinks, but that's what I'm dealing with.
It's also kind of like training your supplier, your partner, whoever you're working with. We're going through the same thing with DLC. If they send back parts bad one time, you could easily say, well, screw you, we're never going to work with you again. But you're going to have the same sort of problems with the next guy, right? So
right, you're right. You'll be out of DLC applicators before you know it.
Exactly. So it's kind of forming a partnership, and as long as everybody's kind of working happily together, then you can hopefully overcome these hurdles and create a good friendship going down. That sucks.
Yeah,
though.
exactly. It's a relationship thing at the end of the day. It really is. We're in this boat together. It needs to be a win-win. Sure, I could cram down a fix, but the reality is, you don't treat somebody like, even when it's their mistake, and then use them again. So I've now got to build a new relationship with a new shop. This is a specific part that is a little bit of a quirky thing to make. Anyway, John, you've kind of run the gamut. I know you brought a lot of your stuff in-house because you've been frustrated with this, and you have this sort of phenomenal obsession with quality, and I respect you for it. But like you've been through the stresses of dealing with vendors, right?
Absolutely, yeah. Yeah, I once had some lathe parts made a couple of years ago from a well-known knife maker with a very nice machine, probably as good as my Nakamura almost. And the parts came back plus or minus 2 thou. And I was like,
what?
What? Are you kidding me?
Right.
Yeah, I got to use like 20% of the parts. And at that point, I was just like, well, screw you. I'm not going to use you again.
Right. I used to have this, an old boss who was really good about framing the context of these conversations, and he used to make fun of MBA students for basically, you take the textbook approach to well, these are out of spec, and you just all of a sudden pound your fist and start yelling and demand, non-payment or whatever. And it's like, well, it's just not how the world works. You gotta, that machinist that you sent them out to obviously is successful. He probably didn't, it's not, mean to have that as the outcome. So it's like you said, you've got to be smart enough about your parts to explain what's important, what's not important. The same reason why I mentioned not over-tolerancing drawings. If you put so much noise on there, if there's 27 call-outs, but 3 of them were super important, sure, the drawings are the drawings and blah, blah, blah. It's important that they're right, but at the end of the day, you've got to give somebody something to work with.
Exactly, and there's realistic tolerance, and then there's unrealistic tolerance. Like
like you.
Yeah, and I'm finding that too. With just making my own parts. Like some diameters are super critical, but not everything.
Right.
And like yesterday, I made 50 pivot screw heads, and the thickness of the head is supposed to be about 30 thou. Mm-hmm. And I realized this morning, I woke up and I thought about it first thing, and I was like, I don't know if I measured the thickness of that head on any of the screws.
Because it's not that critical?
It's got a range. It's a pretty sloppy range, maybe a thou, thou and a half.
You're funny.
But if it's out of spec, then they're garbage. And I realized I made all of them without even thinking of measuring, because I don't have a print. I don't have a print here for this part because I don't think about it. I just kind of know in my head, like, oh, it's supposed to be about 30 thou, but I don't consciously measure this kind of stuff. Like I don't have a checklist to say measure this, measure this, measure this, and it's something I need to move to. Because the process needs to be the expert, not the John Grimsmo, because John Grimsmo likes to forget things.
No, totally. I did that too. I pulled off some parts, and I can't remember what they were 2 days ago, but I was like, how did I forget to check that? Yeah. Not only does everybody, but I think as entrepreneurs, I am always, it's a comedy of errors sometimes, how I'll be like 6 things deep. I'll be doing something, I get distracted to something, which then goes 6 times deep, and I'm like, wait, what was I doing in the rewind?
I get that all the time.
I had to laugh. I was like, what shenanigans was John into that he actually got stuck at the shop in a snowstorm overnight?
Yeah, I did that.
What?
Well, I came home, and then I was like, okay, let's just go back to the shop and put on another pallet. I'll be there for 25 minutes, and then I can go home.
I love that conversation to the wives when it's like, sweetie, I just got to go swap out parts. I'll be right back.
Yep, exactly. and then the next day I come home.
You've been cheating on me with my Mori.
Yeah. I've got work to do.
Was that fun, or was that, I mean, it sounds like you didn't sleep very well.
I did not sleep very well. So for those of you listening, I put up a YouTube video about this. And basically I got snowed in at the shop, and stayed here all night. Couldn't sleep, so I just worked all night. Kept both the Mori and the lathe running nonstop, which was fun. Like it was really cool, actually. And I wasn't like I wasn't working as hard as I do during the day because I have the machines running and then I'm doing other stuff. I was trying to relax. I was trying to get some sleep while the machines were running.
Right.
Just on my computer watching Netflix, while between pallet changes and things like that. But yeah, I couldn't sleep, and it was both fun and stressful at the same time. But
do you have it in you, like the stamina or whatever, to function the next day? Like, can you pull all-nighters?
not anymore.
Yeah,
I worked.
me neither.
I stayed at the shop till about 12 or 1 o'clock, and then I went home and slept for 3 hours.
Right.
And then it's like 2-3 days later, and I'm still not back on schedule.
Right. It's not worth it in the end unless you have some crazy deadline to meet.
Exactly.
Yeah. I can work till midnight for sure, like no problem. Go home, go right to bed. But I can't. The whole overnight thing just doesn't. I don't even take red eye flights anymore.
Yeah.
It's no good.
It just adds a lot of unnecessary. We're getting too old, man.
Right. I hear you. No, the other thing I wanted to mention, which is something I think, something that we've done well about is kind of goes back to the whole vendor thing and building out, that entrepreneurship thing of opportunity, resources in the team, and the resources or team, either one kind of being including the people that are around you to help you, including vendors, because we've talked about so many times before, you don't do it alone. Even you have to get stuff water jet or certain post applications, DLC, tumbling.
Yep.
And what I've always done over the years when I've moved from the East Coast to here and started into different things is I've sent out smaller runs of things that are effectively break even at best. Maybe we even lose a little bit of money just to start building relationships. So we've sent out things to different laser shops. We sent out things to different 3D printers. We sent out things to different tumblers, to anodizers, because it lets you get a chance to see who's good to work with. And sometimes it's not even who's the best, it's just who's the good fit for you. I happen to be the kind of person, like right now I'm working with a vendor that I'm thinking about leaving because they get so annoyed when I call them. Huh. And I don't nag them, but I do have to know, I do need to know some form of scheduling. I need to know, are these parts going to run this week or next week? Just some general idea of that. And that's something that they clearly aren't good at working with. Mm. They're more of a, get us the parts, we'll get them back to you. No, it's not going to be 3 or 4 weeks or whatever, but don't bother us. I hate that,
Yeah. Yeah, you and I were such kind of friendly guys that we want to make a relationship with people we're going to work with.
Right.
And I feel that way too. And, I have that with my lathe dealer, Elliot Matsura, and I don't have that with DMG Mori. So, I'm talking to the Nakamura dealership a couple times a week, constantly, just to keep in touch. And they're always stopping by and hanging out and helping me and teaching me stuff, and it's a great relationship. Yeah. But every time I call Mori guys for questions, I get like a short, terse answer and doesn't even fully answer it.
And again, it's because there is no such thing as DMG Mori. There's only people that work for them. Yeah. And did you buy your Mori before they? Oh, I guess you're in Canada, because in the U.S. there was this big hubbub about when they dropped Ellison and went direct.
Yeah, it was right about the same time, maybe just before.
Okay, how did that work in Canada though? Was it?
I forget. I don't know.
But you don't have a reseller. You were in your paperwork and everything was direct to DMG.
It was DMG Mori Ellison is what the paperwork said.
Oh, it was Ellison. Okay.
Yeah.
Interesting.
Yeah, I forget.
Maybe that's, regardless.
Yeah, it was a big hubbub right about the same time.
Right, but it's funny too, because that's different for our friend on the west coast of Canada who has a DMG who does have a pretty good working relationship. Yeah. Right?
And maybe it's how he is dealing with them and contacting them versus how I do it. I just kind of stay away, and I ask my Nakamura guys how to run my Mori.
Hilarious.
Because they'll answer. I know they'll answer, right?
Right.
So.
Yeah, that's funny. Are you willing to share what you texted me last night about your new?
So on the lathe, in order to hold Grimsmo tolerances and just to be able to do what I want to do, to compensate for tool wear and thermal growth and things like that, I just ordered a Renishaw Turret Probe for the lathe so that I can inspect parts mid-machining, mid-turning. Which I'm super excited about. I've been on the fence for a couple months now, and I finally pulled the trigger and got it done. Should be here in about 2 weeks. And basically that'll allow me to rough turn the diameter, probe it, measure it, and then finish turn after compensating for some offsets. And then the goal is to make, hold 1 or 2 tenths all day long.
So is that just like the Renishaw probe that you see in my Haas your Mori, like the OMP40, where it's just got a stem with a ruby?
Yeah, exactly the same. Except it's called an OLP for lathe.
Got it.
So it's a bit stronger duty because the turret on the lathe is quite violent.
Dude, your turret whips around.
It really does.
That's crazy.
Yeah. So the probe is designed to run production environment on this kind of machine. So I actually talked to a guy named Clinton at Renishaw yesterday for 20 minutes or so, and he just kind of confirmed all my questions and answered all my fears about using it and all that, and it sounds like it'll do exactly what I want.
So you have to stick a gauge pin in the spindle collet and use that to calibrate it, and then you're basically good to go?
I would turn a diameter.
Okay, then mic it.
Yeah, and then mic it so you know what size it is, and you know that a turn diameter is concentric, and you can measure the size, and then you dial it in. So it's going to take apparently 1.5 to 2 days to install it and train me on it.
Holy cow.
So like a half day to install, and then maybe up to a day to train, and just there's all kinds of little macros, just like on your Haas.
Right.
Probably the same macros.
So are you just going to end up using Fusion to post your code, but then inserting by hand midstream macros that do the probing and rest machine or final machining?
Yep.
Or actually, it's not even that hard because all you have to do is update your offsets.
Exactly.
That's all it's going to do. So it's not actually like you have to run variable-based code.
Yeah, you don't have to, but you could. What they were saying is one thing you can do is when you do your semi-finishing pass, you set the offset to like plus 10 thou from the start.
Yeah.
And then you semi-finish, you know it's going to be 10 thou big, and then probe it, and then you can finish pass to 0 once it's set the offset back to 0.01 or whatever it needs to be. But yeah.
That's going to be super cool.
Very excited.
Yeah, so the downside is obviously it's not free and you lose a turret position.
And it adds cycle time. It's funny talking with the applications engineers because that's like their biggest concern.
Yeah, right.
It's like, well, it's going to add cycle time. I'm like, I really don't care. Like,
yeah, you say that. You will care.
Fine. But if it takes a 5-minute part to 5.5 minutes, but makes perfect parts every time, I don't care.
Can you do it every fifth? I mean, if it's truly something where you're trying to deal with like tool wear or thermal expansion, then it doesn't have to be every part, right?
Yeah, you can set up a looping function.
That's so cool.
To basically count up every part, and you can set that to 5 parts, 10 parts, 50 parts, whatever, and then it won't probe until that macro hits 50 or whatever you call it.
Yeah, that's so cool.
Yeah, so I'm really excited about that. It's going to be awesome.
It reminds me sort of the workflow of that robo-drill setup at IMTS where they had 2 robo-drills or there were more, but robot arms that were loading, transferring, and unloading, and between 2 of them there was a CMM that was taking the part out of the first robo-drill, measuring it, and feeding real-time wear offsets back to the machine.
Yeah, I remember that. That was amazing.
Right?
Seeing those kind of cells is like, what?
Well, but that's what you're doing. Yeah. You're just doing it in a contained environment, which costs you some spindle time. But obviously, that's a lot cheaper than a $100,000 external CMM plus robo arm.
Right. Yeah. Yeah. This keeps it all in cycle in machine, and then the goal is perfect parts coming out. And then you can also track, like you can have a deprint function where it actually exports all the probe data.
That's amazing.
It's awesome.
That's cool. Yeah, it was cool to see Jay Pearson. I keep bringing him up again, but he was doing some interesting lathe stuff. They're hard turning, so they've actually gotten rid of grinding by hard turning on their Doosan lathe, and they're holding very, very tight. It's funny that as a non-machinist, I always thought it was funny when I've learned that oftentimes harder materials actually turn better.
Yeah.
When you have the right tooling and feeds and speeds. So they've gotten rid of grinding by hard turning, and then same thing, they have a little parts catcher that dumps out to a conveyor and it dumps it off. And they were making these little Venturis that weren't much bigger than some of your parts, but they weren't doing the pill bottle thing. Somehow they were able to successfully get them to go into the parts catcher.
Nice. Nice. I was actually thinking about buying one of their Venturis for a surface grinder vacuum plate.
Oh, interesting. Because you have non-ferrous?
Yeah, to hold titanium parts.
Right. And yeah, it's hard to block them in, huh?
Yeah, because they don't stay down.
Right.
Double-sided sticky tape works, but it's time-consuming and not super perfect. So I thought about making a vacuum fixture for that surface grinder, the Tormac one.
Didn't you have a Mighty Bite plate?
I do still have the Vac Magic, and it's just kind of sitting around, but it's a lot bigger than the surface grinder. It's like a 12 by 12 or 14 by 14 or something, not 6 by 12. So
we did a Wednesday widget. It'll air next week, I think, but where we tried to use the Pearson Venturi pump or adapter thing.
Yep.
But instead of using the Pearson plate, we actually custom made a fixture and just threw a 1/8 inch NPT tap underneath it with no gasket, and it failed. But I think it failed not because of the fact that we made it. It failed because we were intentionally trying to see if we could make it work without a gasket seal, and the tolerances that you would have to have between the part and the fixture are Grimsmo level
like lapped perfect.
Right. So I kind of knew it would fail, but I still wanted to try it.
Nice.
It's like what you said in your video on spending the night in the shop. You're like, it's my business. I'll do what I want.
Yeah. So true. Yeah.
So what's going on today? What's on tap?
Today I'm gonna keep making more of these screws on the lathe, and then I was gonna switch it to I gotta make our little 440 titanium screws as well. Keep the Mori running, making rasps. I gotta do more grinding today.
The cup wheel stuff?
Yeah, the cup wheel, which is actually going really well until about 2-3 days ago.
What?
Eric asked me to dress the wheel again. And then it all screwed up.
Is this the new one yet from Linda, or still waiting?
No, but it's in transit from the manufacturer to Linda, and then she's going to send it to me.
Sweet.
So I should hopefully see that in like a week.
Yeah, that's great. What happened? You just dressed it and they just got wonky?
Yeah, I dressed it and then the size went out, and I compensated the control for the size, but I didn't mess with the code, because what happened was I was doing 35 passes with cutter comp off, so that Fusion knows what size it is.
Right.
And then 15 finish passes with cutter comp on.
Okay.
But there was a variance between the two, so that the first cut where cutter comp comes on, it was taking a heavier cut.
Oh.
And so we were burning some blades and all kinds of problems.
That sounds like a bad process.
Yes. Took me forever to figure it out. So now I'm just doing 50 passes with cutter comp on the whole time. And now it works great.
Got it. Well, that's, I guess, good. You use wear comp or total cutter comp?
Total cutter comp.
You do?
Yeah.
Interesting.
I don't use wear very often unless I'm just tweaking.
Why not?
A size. I don't know.
I feel like I'm still newish to this, and I'm realizing that it's very difficult. I think it seems to be very difficult to mix the two in your CAM library, because it's easy to forget what you're doing and continuity between your tool library and the machine and Fusion and so forth. But I like this idea of just adjusting off of the nominal, i.e. using wear.
Okay.
Make sense?
But in your control, you still need to say it's a 1/4 inch end mill.
Sure, but that's easy to do.
Right. Well, don't you measure the diameter of the end mill on your Haas, like with the tool probe?
Yeah, and it's funny. I something that's been on my list to try to do a better job of figuring out, but it's not very accurate. So often I'm getting readout tool diameters that are bigger than the nominal size of the end mill, and I think that's pretty unlikely, given that the carbide, like a 3/8 inch end mill, should be less, because it started. I believe started right, and of course it could be more if you had run out, but there's no way. There's no way I'm having that much run out in brand new holders of the quality that I'm buying, and so forth. So, short answer is I don't know, but rather than sit there and academically worry about it forever, I've just been kind of ignoring it, because we can hold great tolerances, so it's not that.
Okay.
It's one of those things. Who was I telling? Somebody yesterday about, and we're in the middle of a training class this week, and it's like, unfortunately, you don't just buy these machines and they're perfect.
Yeah.
It just doesn't happen.
There's a YouTube video right there. It's
right.
It's funny.
Rob Lockwood did one of those HSM webinars last Friday, and it was totally eye-opening. It actually made me really want to go back to IMTS and look at machines again from a more educated standpoint, because he was talking about this triangle of speed, accuracy, and surface finish. And one of the great examples he gave is most people would think surface finish and accuracy are the same thing. And he sort of explains that they're not, because if you want to hit every geometrical perfect datum point accuracy, that's probably not going to give you the right surface finish, because surface finish has to do with the smoothness of the control and the nature of the toolpath as it sweeps over the part.
Yep.
And he's basically talking about machines that are beyond even the ones that, certainly ones I own, and probably even beyond yours. I think, sadly, Dura Vertical is a great high-end machine, maybe? How do you say that? You know what I mean?
Yeah, it's no superstar, it's a workhorse.
Right, it's a phenomenal machine, but he's talking about these, Grobs or GFs or Hermleys that have
right.
just crazy, and how they have two different, I think they were GFs, whatever, George Fisher's, that have the same controller, but one has linear motors and is super high speed, low drag, and the other one is more of a workhorse, beefy, and these are both simultaneous 5-axis machines, and how one of them handles code totally different than the other.
Huh.
Like from what you want to get, what you want to put in your smoothing parameters and tolerancing, and how you want that, basically how you want that code to be digested and processed by the controller.
Huh. Yeah, I saw a picture he put up on Instagram showing like 5 different parts. And he said something like the trouble with, what was it, with playing with surface finishes, they're all just different levels of shiny.
That was amazing. That picture was redonkulous.
Yeah, you can't even tell the difference between them all. But
and they all look like they were surface lapped.
Yeah,
like they were those little like mound things.
Have you tried to do much 3D surfacing on your Haas?
No, but it's something I really want to do soon.
Yeah, like,
for sure.
Like machine a sphere or something, just to see how close you can get it.
Well, and I've seen some mold work done on those exact machine.
It's a mold machine, right? VM.
Right. It could do some good work.
Yeah. I've tried hard to get some really solid surface finishes from my Mori, and I struggle with it. I don't know if it's me or if it's the machine, but I've even talked to Lockwood about it before.
I think a lot of it is it's kind of at a pedestrian level, ties back to our Wednesday widget this week, where we actually did a cam off with Rob, where I cammed up a part and then he kind of fixed my cam, and we showed how different the parts looked after we machined them, and how much at that level of importance cam has in terms of, like I said, the smoothing and the tolerancing, the tool path and the tool itself, and how you present it to the work, and it's crazy.
Nice.
Yeah, I want to do that, and I also want to try hard milling.
Yep. That's pretty
fun.
You ever done? Yeah, I do a lot of that.
Okay.
I mean, I'm doing it with my blades right now. They're 60 Rockwell, and I'm...
Are you serious?
Oh, yeah. And I'm destroying, or not destroying, but tearing into the bevel with an end mill. And
with just a regular carbide end mill?
Yep. 6 flute. Not even a special end mill. It's just off-the-shelf 6 flute Lakeshore carbide. Okay. And it's going great. I'm getting like really long tool life out of it.
Isn't that crazy? A regular carbide Lakeshore. I love Lakeshore. We use them all the time, but they're not IMCOs. They're not helicals. They're not the highest end tool in the world. And you're cutting into 60 Rockwell? Mm-hmm. That's honestly crazy.
I don't know if they're any worse than IMCO. Like, I don't tell any difference. I've tried a lot of IMCO stuff. I've used a ton of Lakeshore stuff, and I think they're the same.
Sorry, thank you for saying that. What I mean is more, they're not the pricing of those higher end ones.
Very good point. Yeah. They're certainly a budget-conscious end mill, and they're great. I use them 90% of my stuff. But yeah, it is crazy that you can cut 60 Rockwell with like whatever carbide is, 70 Rockwell or something like that.
Because a 60 Rockwell steel part, you cannot file it, right?
Right.
A file just skates over it.
Yeah, a file's going to be, 50 or 55 or something.
No joke, if our Haas weren't running a job right now, I would walk out there after this podcast and try to hard mill something.
Yeah. Do you have anything hard?
I've got case hardened stuff. Hardest thing I can think of would be metrology stuff, which I don't really want to mill into.
Exactly. What about a
yeah.
parallel or something? I don't know how hard they are.
That's crazy.
Yeah.
I've got some ball screws laying around somewhere that I don't care about that I could take a edge off of or something.
Oh, yeah. No, it's funny. Like if I'm cutting say a 1/4 inch end mill and I'm just going down, you don't want to go too deep. You want to take very light axial passes, but
Okay.
go down 10 thou and
Sorry, light radial or light both?
light and Z.
Yeah. Light axial, but you can do more of a bigger width of cut?
Yeah.
Okay.
Yeah, like I've got, when I cut a tab off of the blade, I take an 1/8 inch end mill and I just step down like to 10 or 15 thou or something like that.
You're hard milling with an 1/8 inch end mill?
Oh yeah, it's fine. And it leaves some pretty crazy good surface finishes.
Right, because
the material just takes a cut so nicely and it's shiny. And
is it a true square corner, or does it have a slight radius?
a square, it certainly eats up the end mills quickly. And actually now I am using a radius end mill for that same job. Radius will last a lot longer.
Like a 3 thou radius or 15, 20 thou?
30 thou.
Okay, so bull nose.
Yeah, exactly. Just because I have some slightly dull bull noses that now kick up a burr in titanium, but now I can use them for hard milling.
Oh, no kidding. That's funny. That's so cool.
So it's like repurposing
What do the chips look
tools.
like?
Very small. Golden if you're doing good. Blue if you're doing really aggressive.
Yeah.
But yeah.
But it makes a chip. You get a real chip. It's not like a grinding dust.
Yes, absolutely. Yeah, you get fine, small chips. Although when I'm doing the bevels, I'm cutting almost 1 inch depth of cut at like 10 or 20 thou step over.
Is that hardened?
Yep.
Holy cow. Okay, so that's your traditional high-speed type cut where you're...
Yeah. And I'm going at 70 inches per minute, something like that.
Which is fast.
That's pretty fast, really fast.
Yeah.
And the chips, they're 1 inch long spirals. They're look like corkscrews.
What's RPM-ish?
5,000, I don't know.
Okay. Nothing. Actually, it's fast. For steel, that's a good surface footage. I assume it's like a 1/2 inch end mill or something?
Yeah, it's
thicker?
3/8.
3/8, yeah.
Yep.
That's cool.
Because for that length, you need the strength.
The core, right,
Yeah,
right.
yeah.
Do you do any like crazy 7 or 9 footers?
I've bought some 7s, but I don't think I use them very much. I'd like to, for sure. Especially for this application.
MCO dealer just gave me a couple of 6 fluter that they are they're sort of, what do they call it? They're Omega,
Yep.
regular old,
Yeah,
steel.
I've got some of those, yeah.
They're supposed to be pretty good.
Mm-hmm. They're variable and good stuff.
Kind of curious. Cool. Awesome. Well, good luck crushing on this is like boring now. You just got everything dialed in and locked down.
I know. Now it's just keeping everything running and not forgetting to do certain jobs, and got to figure out a process flow, like an actual written down. Yeah, I guess that's something I'd like to do more of is start to track and manage and process control this kind of stuff, so that you don't forget to measure this one tolerance.
Why don't you do, I don't know if this is cheesy, but one process thing a day?
That's a very good idea.
It sounds like today you probably have a little bit of free time. You just in the sense you got machines running. So
Right.
Create a, I started, we bought a $30 Amazon Basics laminator.
Okay.
And so I've been starting to print out workflows and setup sheets for repeat jobs and stuff that we make. And I just, even though I know we're going to change them, I don't care. I laminate it and I put them over on the rack with those parts. And it's cheap, and it's something that doesn't get coolant on it. And the guys, when it's laminated, you tend to respect it more than just a piece of paper.
Interesting. I would see that, yeah.
And as soon as we need to update it, we throw it away, print out a new one, and re-laminate it. Who cares? So I go through an extra $30 of laminated paper or laminated sheets a year. Doesn't matter.
Right. That's funny, because with stuff like this, I talk myself out of it so easily. Because it's like you tell yourself things like oh, well, I'd change it, or I want the ability to add to it or write to
right.
it.
Right.
So you just end up not doing it, which is kind of stupid.
It's like Kaizen foam. Just cut it. Who cares?
Exactly. If you need to do
tell
another
yourself.
one.
Yeah, exactly. Although I'm actually guilty. I want to redo my Kaizen for my desk, and I keep not doing that.
Yeah.
I should do that. I'll do that this weekend.
That's interesting, because, all these little setup sheets and measurement and prints and all that. And then you keep it with the material?
Well, we're doing, for the products that we make where we have a better lockdown workflow, we're doing these Sam's Club rolling carts. So it lets us store, there are 6 shelves, and they're pretty rugged. They'll let us wheel around so we can move them, which I think is important.
Is it a
And-
toolbox?
Nope, no, it's just a stainless steel, it looks like a retail rack,
Okay.
shelf.
Yeah. Okay.
But I think the whole thing will hold like 500 pounds.
Yeah.
And so we can have fasteners in little bins of red, we have the little red Schaller bins on them. And then we can have some of the boxes or packaging, and we can have work in progress. I don't store a lot of finished inventory on them because usually that gets too heavy. And then you can store those cards on there as well.
And are yours full size 8.5 by 11 or smaller?
Right now, yes, but I think I want to start laminating the like smaller card sizes, and then you can staple them or tape them or something to a Schaller bin or a little product or whatever.
Yeah, that could really help us out actually, because even the heat treat process, we're doing these Damasteel pocket clips, and the pocket clip takes a different recipe than the blades do for heat treating.
Oh,
different
interesting.
temperature, different time, and my father-in-law was doing the heat treat, and he picked up a packet, and he didn't know the clips were in it. He thought it was just a blade, so it got heat treated wrong.
Right.
And then that led to problems downstream, and
Right.
all these things like you think you got it, you think you know it, you think you know the recipe in your head, but in fact it's just numbers in your head, and you can't always trust them. So having little process sheets, it's got to be done.
Yeah, and then just, I don't know, paper clip or clamp it or somehow.
Magnet it or something.
Yeah, exactly. Easy.
Yep.
Do it.
I will. I like the
Good.
one a day thing. That's a very good idea.
Yeah, awesome.
Sweet.
Crush it, bud. I'll see you.
You too. Have a
Take
great
care.
day. Bye.
Bye.